I am L.vasthina Sherlin, Standard 8, studying L.vasthina Girls Higher Secondary School. I am also a student of Junior IAS Academy. In this video, Standard 7th, Science, Atomic Structure. What is alpha particles in detail? Welcome friends. Pleasure morning to all. Today we are going to discuss about Standard 7th Science Atomic Structure. The topic is Atomic Structure Part 2. We can also think of a watermelon. You know, the positive charge in the atom is spread over like the red edible part, while the electrons are scattered in the positively charged sphere like the seeds in a watermelon. Now, Thomson made two observations. First, an atom consists of a positively charged sphere and the electrons are embedded in it. Second, the negative and positive charges are equal in magnitude. So, the atom as a whole is electrically neutral. Now, the experiment didn't stop there. A few years later, Ernest Rutherford, one of Thomson's students, ran some tests on Thomson's plum pudding model in its experiment. Rutherford fired a beam of positively charged particles called alpha particles on a very thin sheet of gold foil. Now you are probably going to ask, what are alpha particles? Alpha particles is a positively charged particle having 2 units of positive charge and 4 units of mass. It is actually a helium ion with a +2 charge. Alpha particles are emitted by radioactive elements like radium and polonium. The fast moving alpha particles have considerable amount of energy. They can penetrate through matter to some extent. Now, talking about the gold foil reminds me of a thin layer of silver sheet on Indian sweets. You must have seen it. Yes, it is edible too. But you may also know that is it very fragile. So thin that is breaks even if you place a finger on it. Now this gold foil was a thin as that. Getting back to the Rutherford experiment. He placed such a thin foil at the center of a circular detector. Now, what was the detector used for? The detector would flash if an alpha particle hit. If these alpha particles had so much mass that Rutherford was mighty sure that when he would fire them, all of them passed through the gold foil and hit the detecting screen on the other side. But here comes twist. When Rutherford fires the alpha beam, something strange happened. This is what he observed first. Most of the fast moving alpha particles passed straight to the gold foil. Second, some of the alpha particles were deflected by the foil at small angles. Third, 1 out of every 12,000 particles appeared to rebound in simple words. Some of their four particles went through and hit the detector, but Rutherford noticed that the detector was flashing from various angles. So he realized that some of the particles were deflected by the gold foil and hit the detector in different locations. Some even directly went back to the part they came from. So this is what Rutherford had to say. This result was almost as incredible as if you fired a 15 inches cell at a piece of tissue paper and it comes back and hits you. So the present concept of an atom that we all know is given by Niels Bohr. Let us study the postulates of Bohr's atomic model in detail. Here is the first one. An atom is made up of three particles. They are electrons, protons, neutrons. Electrons have negative charge. Protons are positively charged and neutrons are neutral in nature. The number of protons and electrons in each atom is equal. This makes the atom electrically neutral. Second, protons and neutrons are present at the center of an atom, which is known as the nucleus. The nucleus is positively charged due to the presence of protons. Third, electrons revolve around the nucleus in a fixed circular path called an energy level or a cell. Now, we can represent these energy levels either by letter like K, L, M, N and so on. That is the first orbit is denoted by the letter K, the second orbit by the letter L, third by M and so on. All they can also be denoted by numbers like 1, 2, 3, 4, etc. The energy levels are counted from the center moving outwards. Thank you, friends.